Okay, so we're going to tie this trigonomic unit up. We're going to just use some of the skills we've learned about just trigonomic ratios and be able to use them in finding different answers to different things. So one of the things we want to do is use Pythagorean theorem in our knowledge about those trigonomic functions to find other functions. And then the last thing we'll do is talk about complementary angles. We'll do that in just a second. So here's a sample of this. If I know that the cosine of x equals 15 over 17, can I find tangent of x and sine of x? So that is the question. Like if I'm given a trig ratio, and I don't have a triangle over here, I'm just given this ratio, can I find the others? And the answer to that is yes, because guys, remember, what do we know? I know that the cosine of an angle is equal to the adjacent side over the hypotenuse. So I know that this 15 is the adjacent. I know this is the hypotenuse. For tangent, I need opposite and adjacent, and for sine, I need opposite over hypotenuse, which I have part of what they need. I just need the other part. So what we need to do is use Pythagorean theorem to find the opposite side. So let's just do a drawing here to help us visually see this. So if this is angle x here, that means that this side's 15 and this side is 17, because this is the adjacent side and that is the hypotenuse side. If I want the tangent of x, I need this side over here. Well, I have a right triangle. I just need to find this using Pythagorean theorem here. Remember, this is a squared plus b squared equals c squared. And the hypotenuse is always c here, and then this side's just a or b either way. So what we want to do is we're just going to substitute. So I'd go a squared equals a squared plus 15 squared, because that's what b is, and then that's got to be equal to 17 squared. And then what I want to do is this is just going to be a squared equals 17 squared minus 15 squared. So we're going to find out what value that is and then square root it. So 17 squared minus 15 squared, that gives me 64 here. And so that's what a squared is equal to. I've got to square root this, which means a is going to be equal to 8. So that's what this opposite side is. Now this problem becomes quite simple, honestly, because if I want the tangent of x, I just want to know what the ratio is. And then if I want the sine of x, I just want to know what the ratio is over here. So this is opposite over adjacent, so this would be 8 over 15. And this one would be 8 over 17, because opposite over hypotenuse. This is what you're looking for to answer this question. Okay, because that's what that ratio is going to be. I don't need to know anything about the angle measurements. I just need to kind of know some basic knowledge about these functions and finding other sides. Let's do one more like that. So I've got the sine of x is 39 over 89. I want the cosine, I want the tangent. So remember, this is opposite, and this is hypotenuse. So again, I like drawing a picture because, again, that helps me. There's angle x. Opposite is 39. The hypotenuse is 89. And I don't know this side that's the adjacent side. So I'm going to use Pythagorean theorem to do that. So this would be 39 squared plus b squared equals 89 squared, which is going to be b squared equals 89 squared minus 39 squared, which that gives you 6,400. And that's what b squared is equal to. So I'm going to square root that now. And the square root of 6,400 is 80. So this would be b was equal to 80. So that's what my adjacent side is now. And I can find my cosine. The cosine of x. It's going to be the adjacent side, so 80 over the hypotenuse, which is 89. And if I want the tangent of my angle, so there's that part, then I'm going to go opposite, which is 39, over the adjacent, which is 80. And that would be for your tangent. Bada bing, bada boom. So that's just using some knowledge, just kind of some basic knowledge of what you got there. Okay, here's just an idea, just something you guys may have observed, just things to keep in mind. Sine and cosine are what we call complementary of each other. The question is why, and to kind of understand why they are complementary of each other, and what complementary is, let's look at this. So complementary means that their angles that they use add up to 90 degrees. Okay, so why is this? Let me show you with just again with a visual here. So let's say we've got our angle, our triangle here, okay? And let's say we've got this 3, let's say this is 4 feet and this is 5 feet. And I have angle A here, A, B, and C. If I asked you what the sine of A was, you would go opposite of A, which is 4, over the hypotenuse, which is 5. So this would be 4 over 5. If I ask you what the cosine of B is, what's the cosine of B? So now I'm at this angle, adjacent over hypotenuse, that's 4 over 5. So what I want you to notice is that the sine of A is equal to the cosine of B. And there's something that's really unique about A and B, their angles here. So if you remember, the inside angles of a triangle sum to 180 degrees. Well, C is 90, so we can get rid of that 90 degrees, which means A and B have to equal 90 degrees, because 90 plus 90 gives you 180. So whatever A is, when I add it to B, it's going to give me 90 degrees. And that's why these are complementary to each other, is they're complementary of each other as long as A and B add up to 90 degrees. So let me give you an example. So if I had the sine of 10 degrees, so angle A was 10 degrees, that means that has to be equal to the cosine of 80. That's going to be the same ratio for that, whatever those angles are. So this angle and this angle have to add up to 90, and then you have to have your opposite angles. So if I had the sine of, let's say, 25, that would have to be equal to the cosine of what? Again, it has to add up to 90 degrees, so that would be the cosine of 65, because that would give you 90 with the 25 and the 65. They're complementary of each other because those angles add up to 90 degrees. That's why they call it complementary. Let's say I had the cosine of 50 degrees, and I asked you what does the sine have to equal to? Well, that would be the sine of 40 would be what you'd have for that. Okay? So the general rule is if I have, like, let's say I had the sine of x, what would that be equal to with the cosine? Well, just 90 minus x is what that would be equal to, because you're always going to go 90 minus whatever this angle is. That's the general rule. But that's why they're complementary of each other. Pretty neat little pattern that they follow. That always happens with these right triangle trigonometry. So that's it. This has been your Math Moment with Mommy. Adios.